Ubuntu, SUSE, Amazon Linux, and Red Hat walked into a bar reserved exclusively for Linux distributions. They were sitting around proudly discussing the powerful Linux kernel they all shared, when suddenly a tiny Python script crashed the party and exposed one of the most serious Linux vulnerabilities in recent years. A critical flaw known as copy fail, officially tracked as CVE 2026-31431, was recently discovered deep inside the Linux kernel. What makes this vulnerability especially alarming is that it had remained hidden for nearly a decade before being uncovered by an AI-powered security analysis system. The flaw reportedly existed in kernel code dating back to changes introduced between 2015 and 2017, meaning it affected millions of Linux systems around the world.
The discovery quickly gained attention because almost every major Linux distribution was vulnerable. Ubuntu, Debian, Arch Linux, Red Hat Enterprise Linux, Amazon Linux, SUSE, and countless others all shared the same underlying kernel code. Since the Linux kernel serves as the foundation for servers, cloud infrastructure, embedded devices, and desktop computers, the potential impact was enormous. Security researchers warned administrators to apply updates immediately because attackers could use the vulnerability to gain root privileges and take complete control of affected systems. Reports from cybersecurity organizations indicated that the exploit was already being used in real-world attacks, while government agencies added the vulnerability to lists of actively exploited security threats. The exploit itself is surprisingly small, consisting of only a few hundred bytes of Python code. Despite its size, the script is capable of abusing a logic flaw inside the Linux kernel to elevate privileges from a normal user account to full administrator access. The vulnerability revolves around a Linux cryptographic feature called Authentication Encryption Extended Sequence Numbers, commonly referred to as ESN. This functionality is accessible through the AF_ALG interface, a mechanism that allows user space applications to interact with kernel cryptographic algorithms. Under normal circumstances, the feature works safely and performs cryptographic operations as intended. However, researchers discovered an unusual behavior that could be manipulated in a dangerous way. The flaw occurs because ESN writes temporary scratch data into what it assumes is a valid cryptographic output buffer. Due to a separate bug involving Linux splice operations, that output buffer can unexpectedly reference page cache data belonging to a read-only file. As a result, an unprivileged user can force the kernel to overwrite 4 bytes within cached file data. Although 4 bytes may seem insignificant, they can be strategically modified to alter the behavior of critical system binaries. In the public proof-of-concept demonstration, researchers targeted the SU binary, a program found on virtually every Linux distribution that allows users to execute commands with elevated privileges. By carefully manipulating cached file contents, the exploit eventually grants full root access. One important limitation is that copy fail cannot be exploited remotely. An attacker must already have some level of access to the target machine. This could occur through a compromised application, stolen credentials, SSH access, or another security weakness that provides a foothold on the system. Even with this restriction, the vulnerability remains extremely dangerous because privilege escalation exploits are often the final step attackers need after gaining initial access. Once root privileges are obtained, an attacker can install malware, steal sensitive data, disable security controls, and maintain persistent access to the machine. Perhaps the most fascinating aspect of the story is how the vulnerability was discovered. According to reports, an AI-powered security agent was given a relatively simple research prompt related to Linux page cache references and cryptographic scatter lists. Within roughly an hour of automated analysis, the system identified a previously unknown kernel flaw, traced the vulnerable code path, and generated a working exploit. The event demonstrated the rapidly growing capabilities of AI-assisted security research. Vulnerabilities that might once have required months of manual auditing can now potentially be identified in a fraction of the time. While this creates power